Okay, so we continue with the section 3.3. We had stopped here after explaining what do we mean by two complex numbers being equal to each other. The next thing we are looking at is to simplify radical expressions. Well, these type of expressions you might see they appear in when you are solving a quadratic equation. So you might end up getting a square root of negative 49. So you should simplify it. It can be written as 7i, because if you had just 49, then the answer would be square root of 49 is just 7. But if I have a negative sign with the 49, so if I have what I have here in the problem, negative 49, so that will be 7i. Next one, square root of negative 5. So we can think of it as square root of 5 times square root of negative 1. So this one is I, and then square root of 5 just stays there. Similarly with the C, we have a negative 16 over 9. So we can think of it as negative square root of negative 1 times square root of 16 over 9. The square root of 16 over 9 is 4 over 3. So I am getting I 4 over 3 or 4 over 3i. Now when we have 48, this is not a perfect square, but we can pull out some perfect square from there. So what is the maximum, the biggest square, whole square in there? 16, because it can be written as 16 times 38 is 48. So sorry, 16 times 3 is 48. You may check that. So I can write it as square root of 16 times square root of 3 times square root of negative 1. So I get 4, I can simplify it, 4 square root of 3 times I. Same thing you can do with E. Write it like this. Now the square root can be split. So remember, this is the rule. If you have a square root on a fraction, it goes through both the numerator and the denominator. So using that technique, this is our answer. Now how do we add complex numbers like we do in algebra? Put combine the like terms. So here I had 3 minus 2i, and the second expression is this. Second complex number is that. And so first thing I do is remove the parentheses. So I just rewrote the terms, then I rearrange them. I put the terms without the I or the real parts together, 3 and negative 5. So I have them together here, and then I took the other two which are the imaginary parts, so that is 2i and 3i, and I put them over here, negative 2i and minus 3i. Now the first one gives us 2, so it will be equal to negative 2, because 3 minus 5. But what about the other one? Well, we on a side I go and I take the common denominator, and this gives me negative 7 over 3i. So that is our answer. What about the next part? So it is negative 4 plus I minus 2 plus 5i. Remember, this negative has to split, it has to be distributed. And then I combine the like terms, so I can combine the negative 4 with the negative 2. If you want to do this middle step by putting them together like I did over here in the previous problem, you may do it. If you don't want to do it, that's still fine. So negative 4, negative 2 gives you negative 6, and 1 plus 5 gives you 6, so plus 5i. So that will be your answer. Now how do we multiply a complex number? Again, very similar to the process we do in algebra. So we use the distributive law, or so one by one. So first I will take this first term of the first binomial, multiply it with the first term of the second and the second term of the second, and then I will add to it the product of the second term of the first with first and then with the second. Yeah. So let's do it. So we have 2 times 3, which is 6, minus 14i, and then wait a minute, I think there was a negative sign with 2. I have hidden just to be sure. Yeah, there is a negative sign with the 2. It got hidden, so I had to remove those. Yeah, so let's start over. So we have negative 2 times 3 is negative 6. Then negative 2 times 7, negative 7i will be plus positive 14i. And then the second term of the first complex number. So I into 3. So I get plus 3i. And then I into negative 7i gives me negative 7i squared. So you see there are 2 terms which have I in them. So I can combine them. So the first one is negative 6, just stays as it is. When I combine the middle two, it gives me 17i. And then minus 7, but I square is, we know, is negative 1. So this can be written as negative 6 plus 12, 17i plus 7. Because negative 7 times negative 1 is positive 7. So this now can get combined with the negative 6 in front. So we get 1 plus 17i. Now similarly, we can multiply this second one. Now these are weird numbers. Okay, so first 2 over 3 times 1 over 6. So 2 over 3 times 1 over 6. 2 goes into 3, 6. 2 doesn't go into 3, 2 goes into 6. So we have 3 here, so we end up getting 1 over 9. So 1 over 9, and now we have to multiply. Now we have to multiply the 2 over 3 with the negative 24i. So 2 over 3 times 24. 3 8s are 24, so I get 16. So minus, there was a minus sign, so minus 16i. Then we are done with the first term. Now we go to the second term of the first complex number and multiply that with the 2 terms of the second complex number. So positive 12i times 1 over 6 will give me positive 2i. Now positive 12i times negative 24i will give me a negative number. But what's the number? So we have to multiply 12 with 24. So what will that be? So 24 times 12. 12 4s are 48. 12 2s are 24 plus 4, 28. So 288. So I have negative 288i squared. Okay, so now we can simplify these two. and this from here we know I square is negative 1. So this will give me 1 over 9 minus 14i, middle term is 14i. Now this becomes plus 288 because the I square is equal to negative 1. Now you notice that this is a real number and this is a real number, so we need to combine these. We have 1 over 9 plus 288 then minus 14i. So do the addition of the 1 over 9 plus 288 on a side. 9 8s are 72. So we put the 2 here and then 7 is carried. So 9 8s are 72 plus 7 79. Then again we put the 9 and 7. So 7 now 12 into 9 into 18. 18 plus 7 gives us 25. So 2592. That is what we are getting. But then there's a 1 plus, this is what we get, 1 plus 2592, which means 2593. So I get my answer as 2593 over 9 minus 14i. Next we look at powers of I. So for that, first we start with the power of 1. Well, 1 means the quantity remains the same. So I to the power of 1 will be I. I square we know is negative 1. I showed you why. And once more time, it's using the rule, algebraic rule, that if you have a number, square root of a number times square root of the same number, then you get back the number. So now, because square root of negative 1 times square of negative 1 is I times I, which is I square, which is equal to negative 1. And the next thing is I to the third. Well, to compute that, you can use the rules of exponents or exponential rules, with properties or rules. So if you have I to the third, I can think of it as I square times I. So I square is negative 1. So this will be negative 1, and then we have I. So answer will be negative I. That's what I'm getting for I to the 3. What about I to the 4? In the same way that I just showed you here, I have to break the powers of I. So now I to the 4, I can write it in many different ways, at least 3 I know, but pick the easiest one. So I square times I square. I square is negative 1. So negative 1 times negative 1 is 1. So we end up getting a 1 for t to the 4. Then t to the 5. T to the 5 will be, so you can do the similar kind of. So here on the right side I have done those. I to the 5 can be written as I to the 4 times I. We know I to the 4 is 1, so we get 1 into I, which is I. And then t to the 6 we can write as t to the 4 times t to the 2, I to the 2, and I to the 4 is 1, and I to the 2 is negative 1. So we end up getting negative 1. Now what about t to the 7? So t to the 7 can be written as t to the 6 times t. So t to the 6 we just calculated is negative 1. Sorry, why do I keep changing the I to the t? So we have I to the 7 will be equal to I to the 6 times I, so which can be written as negative 1 I times I or negative I. That's what we get for t to the I to the 7. And then I to the 8 will be, again we can think of it as I to the 4 times I to the 2. No, I to the 4 times I to the 4. So I to the 4 is 1. So I'll get 1 into 1, which is 1. So if you look at these two rows, we are getting the same values. The values are repeating. So after every fourth power, the values will repeat. What this tells us is that if there is a number n as a power of I, then we can divide it by the number by 4 and use the what we call the division algorithm. So when we divide n by 4, we can write n as 4 times some quotient plus some remainder, because the divisor is 4 here. So what will happen, I showed you here, if we replace the n power of t by this expression 4q plus r, then we can do some algebra and rewrite this, and then we see that we are getting just I to the r. So that's what we are going to do. For the first one, we have the power is 9, so divide 9 by 4. So 4 2s are 8, and then we have one remainder. So this will be I to the 1. So I to the 9 is the same as I to the remainder. So remainder in this case is 1, and so we get just I. Second part, square root I to the 84. So our number or our n is 84 here, and then we do the same thing, we divide 84 by 4. Now the remainder is 0. So we said that I to the 84 is the same as I to the which is 1, because any number raised to the 0th power is 1. Okay. I to the 103. So we have now number 103. Dividing it by 4. 4 2s are 8. And we get 2 as a remainder, and then we bring down the 3, and then we divide again. So 4 times 5 is 25, which is bigger than 23. So we have to come down. 4 times 5 is 20. Sorry, 4 times 5 is 20. So we are left with 3 as a remainder. So this will be the same as I to the 3, which is equal to negative I. Now we have I to the 62. The 62 can be written as okay, so 62 divided by 4. So 4 ones are 4, 2, and then 2, and then 4 5s are 20. So the remainder is 2. So it means this will be the same as I square, which is negative 1. So this is how you can find the power. So I will stop here and the rest in the next video.